Assalamualaikum and very good morning to all. Welcome to Ferran Technology Public Live Webinar. My name is Syahadatul Iskandar bin Rosli and I am the Senior Application Engineer at Ferran Technology Berhad. If you are new here to Ferran Technology Berhad, Ferran Technology Berhad is the only licensed, approved and trusted Dassault systems vendor in Malaysia. We are your one-stop center for all Dassault system solution suites. One of our many solutions here is Katia. I'm sure you all have heard of Katia before. We have become the expert team of Katia in Malaysia by working on projects and collaborating together with our business partners throughout the years. And by looking back at those years, we have come to notice that a branch or workbench inside Katia that is so powerful and useful has been sidelined for quite some time. That is called KNOWLEDGEWARE. Okay, today, that is what we are going to focus on in today's webinar. KNOWLEDGEWARE is a pretty large domain to discuss within an hour. Hence, we will only take a small chunk of it for our webinar today. And for that, please welcome two of our application engineers in Ferran Technology Berhad, Mr. Muhammad Hashimi and Mr. zaim.amzar to the stage.
Hey, bro.
Welcome, guys.
Hello.
Morning.
Good morning.
Okay, so glad to have you here virtually. Although we have not seen physically for almost a month now due to the COVID-19 pandemic. Okay, together, these two application engineers will present to us a webinar titled Know-how and Automation. Mr. Muhammad Hashimi here will be in charge of delivering the presentation materials. On the other hand, Mr. zaim.amzar will be in charge of delivering the demonstration materials. Okay, as usual, if you have any questions during this webinar, please feel free to submit your questions in the comment area below. I will bring them up during our 10 minutes Q&A session towards the end of our webinar. Alright, now without further ado, I will welcome Shimi to the center stage to deliver the presentation material of the topic. Over to you, Shimi.
Okay, thank you, Iskandar. Assalamualaikum warahmatullahi wabarakatuh and very good morning. Okay, so let me share my screen. Okay, so let's start with my presentation, know-how and automation. Okay, so this will be my the content for my presentation today. Introduction, industry challenges in paint, KNOWLEDGEWARE values and benefits, KNOWLEDGEWARE concepts, customer testimony, and the last one is summary. Okay, firstly, let's see the meaning of the term know-how and automation. So according to Wikipedia, know-how is a term for practical knowledge on how to accomplish something. And according to Oxford's dictionary, know-how means practical knowledge or skill, or we can say expertise. Therefore, in engineering term, the word technical know-how referred as technical expertise, right? So, whereas the word automation, according to Wikipedia, is the wide range of technologies that reduce human intervention in processes. So, human intervention is reduced by predetermining decision criteria, sub-process relationships, and related actions, and embodying those predeterminations in machine. Alright, so what are the knowledge pains? So these are the typical knowledge pains faced by company or organizations. First, knowledge bottlenecks is a particular skill or expertise is in short supply. So, for example, the limited skillful workers or experts available, so that the knowledge transfer will be limited as well. Then, knowledge capture, organization fail to retain knowledge. The knowledge live with people, okay, which will be big waste for the company or organization. In this case, the company will need more time to train new workers or to hire new experts. will be which is a waste of time. And then knowledge effective applications. The best knowledge available fails to be applied correctly. And then knowledge resources waste. The organization does not really know what knowledge resources it has. Then knowledge and corporate standards. Organizations' corporate standards can be inconsistent, complex, and difficult to enforce. And sometimes it is changed and modified by the company policy. Right, next, what are the knowledge requirements? To leverage competitiveness of companies' need, in particular, the company must be able to identify, model, and explicitly represent knowledge. Then, to systemize knowledge captured by different types of users, to capitalize know-how along the time, then to share and reuse multidisciplinary knowledge across the enterprise for various types of users. Alright, we proceed to the next slide. What is knowledge-based engineering or KBE? Knowledge-based engineering is the ability to create a design with regards to the company's requirement and following company standard or international rules. This knowledge is captured and formalized so that it is directly available to engineer with a certain level of automation to be directly beneficial to the user or other stakeholders. Right. So companies and organizations who aim to become more competitive have to manage their internal know-how lifecycle across the enterprise. So what kind of know-how are we talking about? In this situation, know-how is related to the processes and workflows description, individual expertise, and how people collaborate. Right. In engineering scope, it includes technical drawing, CAD files, bill of materials, existing applications, and also lessons learned by senior designer or knowledge experts. What does it mean to manage the know-how? In the knowledge lifecycle, the experts or senior engineer or designer play important role to share their know-how to the company. All of the information such as industrial needs and technical feasibility need to be identified and justified. Then next step is to collect the important knowledge from related sources. The knowledge engineer then attach the know-how to the PPR model and knowledge-based engineering architect to strategize the development. And then the knowledge or know-how then able to be deployed and used and maintained depending on the requirements by the company or the customer. Both of the process is covered under the knowledge-based engineering. All right, so next, we move to the industry challenges and pain. Okay, so these are the typical pains and challenges faced by company or industry. Complex products difficult to manage due to lack of information from suppliers. Then frequent change of requirements be from suppliers. And then the necessity to rework the design is due to errors and bad working methodology. Long design time due to non-automated process. Frequent schedule violation due to the bad reactivity of supply chain. The right minimum information to exchange or share with the supplier is not identified in internal because of delay due to incompetency of resources. Low quality products could be due to workers did not follow the design rule or company policy. And then last but not least, high maintenance costs because of implicit know-how or lack of competent human resources, badly documented maintenance procedure, and so on. All right, so next, knowledge way, values and benefits. So how, in order to cure all the pains just now, the company has to set up an environment favoring the innovation and in the meantime automating and increase the security of low value added. This will be the result after the know-how automation being implemented in this company. So complex products difficult to manage. So no profilation of products and process thanks to unified working methodology. Then frequent change of requirements. Capitalized strategic knowledge takes into account explicit and tacit knowledge, then enables to react quickly to any requirement change. Thanks to PDM links and the associativity of design, the changes are propagated automatically. Then a necessity to rework and design can be cured by streamlined product development because working methodology is enforced, so the quality of design is guaranteed. Long time design increase performance because the processes are automatized according to the best methodology. The right knowledge is shared among identified communities, the products and the processes are optimized. The next, frequent schedule violation. The employee suppliers collaborate on the basis of shared knowledge. They are more satisfied by their work since they have less repetitive tasks. Then, low quality products is improved since the product ration is well documented and managed as well as the process know-how. The application of the best working methodology is enforced. High maintenance costs is reduced. The management of knowledge harness the collaborative power of the company, and finally stimulates revenue growth. Innovation is speed up. Alright, so next, knowledge ware concept. Okay, so this is basically the package to implement knowledge ware. Knowledge ware workbench in Katia consists of knowledge advisor, knowledge expert, product engineering optimizer, product knowledge template, and business process knowledge template. So the Katia V5 product to capture know-how is for today's webinar, I will be focusing only on two products, which are Knowledge Advisor, KWA, and Product Knowledge Template, PKT. Alright, so the Katia V5 product to capture know-how is Knowledge Advisor, or the telegram is KWA. This workbench provides three fundamental functions, which are rules, checks, and reactions. These functions allow to integrate know-how using the knowledge-ware language and to optimize them in order to facilitate technical decisions, reduce errors, and automate design for maximum productivity. And then the Katia V5 product used to create user-specific features is Product Knowledge Template, or PKT. This product allows creating user-defined feature, or UDF, which is new parametric feature based on a structure composed with existing feature like pad, groove, hole, sweep, etc., or document template, which is part of product startup files, which could be additive to a geometrical context. All this template will be explained further in the next few slides. So in overall, the concept of knowledge ware in Katia covers the process of knowledge sharing methodology, starting from design, optimize, and certify, to capture all the requirements and then to reuse. Okay, move to the next slide. Okay, to have better understanding on knowledge advisor, let's take a look on this scenario. Firstly, the subject matter experts on the left side want to create a design template. With this design template, user or maybe a junior engineer can simply reuse it and adapt to his context in the future. So the expert will create a component with Katia applications, and then he added some knowledge features to enable morphing, such as design requirements, rules, constraints, table, check, formula, and component behavior, and so on to enrich design definition and associativity. Okay, and then the user then can reuse those design directly afterwards and change its specification or parameters based on the design requirement. Alright, and Knowledge Advisor is a CATIA product which allows user to embed knowledge within design and leverage it to assist in engineering decisions in order to reduce errors or automate design for maximum productivity. So for example, in this case, the jigs and fixtures, instead of spending time to design multiple jigs design, we can create one template and use and save it in the library and change the parameters based on our product specifications. Alright, so this is a case study on toe hook assembly component. So this customer, Mascio Group, from Italy, is a leading global supplier for agricultural machinery, including its Mascio soil preparation machinery and Gaspardo, which is planting machines. So they have at least two types of machine with different function. So the one of the business challenges is to reuse existing designs to create more product options. So the objective of this project is to product able to adapt itself to the environment. In this project, they are using a KNOWLEDGEWARE to design an adaptive geometrical construction. Then they create some KNOWLEDGEWARE rules. For example, if the tube length is more than 150 millimeters, so the number of stiffeners will automatically set to 4, okay, as preset by the expert. Okay, and then last but not least is they use the replace operation function. Right, so as a result, this KNOWLEDGEWARE is able to change the component parameters as well as change the component environment. Alright, so next we move to the product knowledge template. Okay, product knowledge template provides the ability to easily and interactively capture engineering know-how and methodology for highly efficient reuse, helping the organization to share best practices and avoid duplication of effort through inability to reuse existing design. We will see how product knowledge template function in this scenario. So by using a product knowledge template, the expert can extract a set of features to define components. Not only using applicative feature, but also knowledge advisor features. Then the expert publish those components and templates through a catalog. And then he may also use a complete part or assembly as a component. And then the user can easily use and reuse those available components in his specific design. Right, so this is the type of templates. Firstly, assembly templates, a whole assembly and it is associated documents to be reused inside products. Once instantiated, the assembly is duplicated and the embedded parts can be independent or reference the original one. And then part template, a part and its associated documents such as drawing, analysis process to be reused inside products. Once instantiated, the part is duplicated and you can get independent component. So both part and assembly templates are templates that works at the part or at assembly level. Okay, next, power copy is a template that is created from a set of features designed interactively in order to be reused in the design of another part. It allows inclusion of all kinds of geometric elements, but also KNOWLEDGEWARE features to add more intelligent behavior. such as parameters, formula, design tables, rules, and so on. Only the main parameters are made accessible for use. Our copy can be saved in CATIA catalog to make it available for all designers. Next, user-defined feature or UDF is a template that works at the part level. From a collection of features like geometry, literals, formulas, constraints, and so on, you can create your own feature. The result is a part design feature or shape design feature that can be reused in the design of another part. The created feature can be saved in a catalog. So templates are applicable anywhere, not only limited to design process, but also in conceptual study, ergonomics, tolerancy, digital mockup, simulation, manufacturing, and up to tooling. And templates also can be applied in many fields of industries such as automotive industry, aerospace, fabrication, electronics, and electrical, shipbuilding, consumer goods, and many more. Alright, so advantage of templates. Full interactive approach. Any morphing template can be completely defined with the V5 interactive application and the KNOWLEDGEWARE products. Natural solution and incremental solution. The templates usually starts from an example that is generalized. The template can easily be enriched and modified after several times. And the templates can be used as a generative approach. End user can quickly generate a new component by reusing the template, simply clicking on the inputs and entering parameter values. And then last but not least, the generated geometric component is still alive. All the knowledge that leaded to the template extension belongs to the resulting model. If the context is changed, the resulting model will morph. The resulting model can evolve separately from the original component. Alright, so this slide you can see the comparison in terms of time consumed to complete a design creation and modification with and without morphing components in CATIA. So the gray color shows the standard design process with CAD system, whereas the blue and orange color represents CATIA V5 with KNOWLEDGEWARE application. At the right side is the features in KNOWLEDGEWARE which have been used. So for example, the toe hook design creation traditionally will take around 4 hours to complete, whereas by using CATIA V5 KNOWLEDGEWARE, the design time reduced significantly to only 10 minutes. Same goes to the design modification process, where the time taken reduced from 1.5 hours using traditional process or standard process in CAD into only 2 minutes with template. And the second one for solid separation assembly, where hundreds of parts and components needed to be assembled. The design creation takes longer, around 3 days to complete without the KNOWLEDGEWARE features, whereas with the feature it only takes 1 day. Same goes to the other two examples, rolling assembly family and manufacturing assembly drawings. We can see a significant time difference, time reduced as a result of template features. Right. So next we go to customer testimony. So first, testimony from Pijo Citron PSA. So the technical innovation, tooling knowledge embedded in powertrain parts and assembly, automatic rule-based system for tooling generation, automated validation process with embedded checks, and interactive and easy to use system. So the business impacts after the implement is KNOWLEDGEWARE, the productivity, tooling design time reduced by 50%, generic intelligent tooling models anticipate changes, and knowledge captured and shared as a reference for all. The next we have Audi, which is most likely with Pijo, intelligent master power copy for tooling flash hills, then rules generate design and propagate changes, automated validation process, and interactive and easy to use system. Alright, so Mr. Muller estimates the CEO estimates that through the ability to integrate standards, KNOWLEDGEWARE will help identify or eliminate automatically 150,000 errors per year. Goals included a 10% to 20% time saving during the initial design process, and a further 30% to 50% time savings during the inevitable design changes. And more larger scale projects was planned. Okay, next we have homage. I will just go through this. We have some more customer testimony from Krebs is industrial equipment in hydrocyclones design and manufacturing. Okay, and then we have Mexo is industrial machinery for paper. And then namely Chrysler, Valeo, automotive. So in summary, summary of the customer testimonial, you can see that all of them experience a positive feedbacks, which is time mostly of time spent for design will reduce dramatically, which meets one of the KNOWLEDGEWARE objective in cost and time saving. Okay, so that's all for now. So back to Iskandar.
Okay, thank you, Shimi, for that very informative presentation just now. So hopefully the basic understanding of what is know-how and what is automation has been delivered to all of you. And now we will move forward to our next segment, which is the live demonstration, which will be presented by Mr. zaim.amzar, and I will bring him back into our stage right now. Okay, over to you, Zaim, to deliver the demonstration.
Okay. Hello, assalamualaikum, and good morning, everyone. So today I'm going to demonstration about KNOWLEDGEWARE. So I will create a simple UDF, and objective here is to create a solid part along the input curve center at the input point and to automate the process through UDF process. Firstly, I will create a new geometrical set. So we rename as UDF basic, and then I will create a wireframe on any plane. For example, YZ plane. Sketch. I will use spline. And then the most important things in UDF is our input must be in datum element. We use datum element as our UDF input to avoid errors during initiation later. So I'm going to disassemble this sketch. Domain only. Okay. So after I convert the sketch to datum element using disassemble, and we can delete this sketch. I will not use it anymore. Delete. And then I will create a second datum element, point datum element on any place. Okay. And then using isolate process. So I will have two datum element here as first. I will rename this as input curve. My input curve, and then this will be my input point. So this is our first step in UDF. So I have input curve and input point. Second, I will create a plane normal to curve, point on input point. Okay. And then I will make a sketch. For example, sorry, I'm using position sketch. Position plane 1 and this one projection point for origin type. Okay. For example, I want to create square and exit sketch. So I will have sketch, curve, and point. And then I will pad this sketch using part design. First, I will insert body, and then I will pad square to cube. Oops, sorry. Mirror extend, 10, review. Okay. Okay, this cube will be my UDF output. Okay. So for the third process in UDF is I want to change this UDF, this part body to UDF. So I will go to insert, knowledge template, users features, and then I will rename this as cube UDF. So I will select this tree from bottom to upper until our datum element. So for example, cube output, and then I select sketch and plane. So this objective of this is to make sure all of our input are refer to datum element. For example, input point and input curve. Okay. So can hide this, and this and this. Okay. I will have my cube PDF, and for example, sorry. So for example, we going to have we get any design requirement from customers. So this one going to be design requirement. And then for example, I got a spiral pattern. So support going to be XY. Center point going to be coordinate 0, 0. And reference direction going to be on Y component. So let me make this bigger. Okay. Okay, this is example for design requirement. It has 2 points, 1 point here and second point here. Okay. Okay, now I will initiate this cube UDF. So after we define the UDF, we can try it out. Notice that each and every time the UDF is initiated, the solid cube is created easily following the process defined earlier. So for example, this is my first input point, and the spiral going to be my input curve. Preview. Okay. Okay. And second cube UDF initiate this point and spiral input curve. Okay. Okay, as you can see, the orientation of this cube will follow normal to curve. So this is concept for UDS, UDF. UDF benefit is to maintain electoral property because UDF doesn't show the history of how we produce the solid cube. If you want to share the process with others, you can use Power Coffee instead using the same process. So what's the difference between UDF and pattern? So pattern, you will not get the cube on the same orientation. This is example of I'm creating a cube and using the circle pattern. So the circle pattern, the orientation of each cube are different. As you can see. So that's for the first demo. And for the last demo, objective here is to automate a wall design and assembly through the same process as before with additional configuration. So Katia will automatically create wall panel accordingly, position correctly and with a control configuration. For example, I have this 5 example of wall panel. So this one, first one, this one is for the first example of the wall panel. As you can see, the connection here, and for the second part, for the second example, I have this connection. And for type, I'm going to have both connection on V shape. So you can see here. So I will create, for example, if I have a design requirement here to create a wall panel, I can easily use this sketch input. We'll create a new sketch input. So for example, any design that I get, okay, this is example of design requirement from customers. Easy. So using sketch element segregation like before, I can, it will create easily and execute. So what it will do, sorry, where we'll delete this again. and I will create another pattern. Sorry.
Zain,
Yep.
I think your view is too far. As you can see, the segmentation length is very large.
Sorry.
Maybe you can resketch the whole thing again and see the sketch tools. The length is quite large. Actually,
Okay. Sorry.
try to start again. All right.
Alright. Thank you.
And that is too small. Maybe you can make a line at the range between 200 mm and below 1000 mm.
Okay. Guys. Okay, this is example of my user requirement. Sorry. And then I will automatically create a surface using each line that I've been create, and then I will go to panel creation and execute this panel creation programs. So execute. What it will do, it will automatically create a wall panel. It will automatically create a wall panel using this rule. So as you can see, my design is too small. So as you can see here, it will automatically create a sketch. So the input just a sketch, and then Katia will automatically create a wall panel accordingly and position correctly using each line and with control configuration. And then I can change each type of this wall panel. I can change each type of this wall panel to or FF. So it will automatically create. Oops, sorry. Okay. So it will automatically create wall panel using my five example of this wall panel. So conclusion for automation is to reduce time consuming for create each plane and to assemble it. So that's all for me. Thank you. Back to Iskandar.
Thank you, Zain. I think there are some problem with the sketch earlier, right, Zain?
Yep.
So the sketch that you use is too small for the model to come up properly, but it's okay. I will give a short break. I think right now. Hold on. Okay, we will have a short 1 minute break. Before we can proceed with our Q&A session later. Just a reminder, you can submit your questions in the comment area below if you have any, and we will gather all those questions and try to address them in our Q&A session after this. So in the meantime, enjoy this short 1 minute video from one of our partners. Our partner here offers a solution for you to manage your online form. If I'm mistaken. I will play the video for you and enjoy the video, and we will see you later after the video finish in our Q&A session. All right. Okay, Zaim, I will put you back in the backstage area for a moment. Enjoy
Okay.
this short break. Okay, guys. Enjoy the video here. For a moment. Okay, so welcome back to our Q&A session. All right, I see some questions in our comment area. Let's see if, sorry, I should bring our speakers to the stage. So welcome back, Zaim and Shimi. Okay, we have some questions in our comment area. I'm just going to have a quick check inside my WhatsApp whether I receive any direct questions from anybody. Okay, so we will proceed with the question submitted in our comment area. We have a question coming from Danalitika. Okay, I hope you guys can see the question below.
Yes. Yes.
Okay. So there's a question coming from Danalitika. The question is regarding parameters. Okay, since there's parameters being used, is it possible to do some automation during design or modification process? I think this question can be answered by Shimi. Can you answer this?
Okay, Iskandar. Okay, so since there's parameters being used, it is possible to do some automation during design or modification process. Yes, it is possible. In fact, much easier to control any design changes and modification by automating the changes or modification. We are changing the parameters value. So we call this approach as parametric modeling. Okay.
I hope that answered the question. Basically, whenever we design our 3D model or our product, we can tie each and every features of our product to certain parameters, right? That parameters have its own value, have its own parameter type, etc. So when we change that parameter type or that parameter value during the design process or after design process, it will change directly the 3D products. So we can have a direct control and we have a bigger dynamic approach to this design context. Okay, And we have another question from Mr. User. Okay. This question came during Zaim's demonstration, whereby we demonstrated that wall panel can be produced directly via a sketch. So is it like extrusion or is it like a normal padding? I think I will let Zaim try to answer this first, and I see whether I can add more points to that later. Over to you, Zaim. Can you answer this?
Sorry. Okay. So it's like extrusion, is it? So for me, I think it's like extrusion, but it will only automate all the process if you do extrusion. So it will be faster than extrusion, I think.
Okay. Um, let me try to add more dimension to that. Normal extrusion or normal padding will take the form of the whole sketch. You see, previously, what Zaid demonstrated is a sketch with I think 1, 2, 3, 4, 5, 6 edges to the sketch, right? It takes the form of a what's the form? I think more towards L inverted L shape, right? So in normal extrusion, the extruded 3D model will follow the form of the sketch, right? But as opposed to that, during the demonstration, the UDF, instead of following the total form of the sketch, it will only take the edges of the sketch, and then from the edges, it will produce sort of a thickness and extrude it up. And apart of that, apart of the thickness, it also has some configurations control to it, as what Zaim demonstrated. We have a wall panel with FF. This is sort of FF shape. And then we also have another profile at the end of the wall panel, slightly smaller than the FF, which is MM. So during the creation via UDF, you can control this configuration simultaneously. All right, so that's the power of UDF, or as opposed to a normal extrusion. Okay, I hope that answers the question. And we have another question coming from Mr. User as well. Okay, is it possible to record or animate the parametric modeling? Okay, I need to digest this and try to understand this in context. Okay, to record or animate. Let's see. If they animate, that by the term of animate here in this question, in regards to we can see the propagation of the 3D products from bottom, and then it adds materials slowly towards the end of the top part. I don't think it is capable of doing that, Mr. User. But if you are saying that if we can animate the parametric modeling, I'm focusing on what Zain demonstrated earlier by the wall panel, right? So if you're saying that if we can animate the wall panel creation from one section and then finish this one section, we can see the wall panel, and then it proceeds to the next section, proceed with the next section, complete with one panel, and etc. Following all the sections until we complete the whole sketch area, then it is possible controlling that inside our script. And for recording purpose, for every CATIA features in CATIA, we have a record feature. We have a record video feature. So you can record the video and replay the video anywhere you like. By default, if I'm not mistaken, the video format output will be in .mkv format. Okay, there there is a clarification on record, I think. Let's see. Do you mean versioning? I think you mean versioning. Okay, for versioning, it is a separate subject, Mr. User. The changes here is directly applied to the current file, unless you maintain your version in your file management system. That is a separate situation. The one that I'm referring here is example. You have a first version, the first version of the design, and then you create another version of it separately in your file management system, not directly in the same file. Okay, that's the versioning. That is in Katia V5. So I think, let's see. Shimi, do you have anything to add regarding this versioning?
No, I agree with you, Iskandar.
Yeah, because Katia V5 is not a database oriented application. If you want to have an automated versioning system, we have an alternative to Katia V5, which we are promoting heavily right now, which is called 3D Experience. So I think we have covered 3D Experience quite a bit during our last webinars. Basically, 3D Experience is a unified platform which combines modeling. By modeling, I can refer directly to Katia actually. It combines modeling, analysis, simulation, and collaboration. So the keyword here is collaboration. So that's where you can use this versioning inside 3D Experience. But as far as Kata V5 is concerned, it is still mainly heavily dependent on your file management system. Okay, another question from Mr. User. So let's say we can apply it for changes in other design. I think this is referring to UDF. Okay. UDF. Any one of you can add more to my answer here. Okay, Zaim, Shimi. For UDF, I think you can view it separately as what you understood by design template. Okay, normally design template is a fixed template, i.e., if you have a product which is in a solid form, solid cube form. Okay, cube. It has a cube solid. So by that design template, whenever you instantiate that design template into a different design, the cube solid retains its form and dimensions. Okay, that's what our normal design template looks like. But in UDF, it doesn't really stay the same. It depends on the design inputs. The new design will alter the UDF in the new design environment itself. So let's say we have a cube solid dimension 1 meter by 1 meter by 1 meter. Okay, that's our initial design template that we created. But in our new design requirement, we need to create the cube solid inside 2 meter by 2 meter by 2 meter design requirements. So by using UDF, we can use the new design requirement environment 2 meter by 2 meter by 2 meter, and when we apply those requirements inside the UDF, the design template will automatically change from 1 meter by 1 meter to 1 meter into 2 meter by 2 meter by 2 meter. I hope it clears. So you can, the question is, can we apply for changes in the design? The short answer is yes. The long answer is what I just blabbered about just now. So, okay. Let's see the next question. Okay, this is sort of a long question. Let's say there's an error when editing the parameters from template. Okay, we need to digest this question. Will there be a prompt to where the error is? Okay. Zaim, have you encountered this sort of error during your demonstration preparation before?
Yep. I have encountered these errors. So what it will show, it will show on a red line to show the errors that I get. So I have to edit. For example, I have to edit a line to get this wall panel to be perfectly assembled using that wall panel. So there's certain setting in wall panel, so it must not exceed 1 meter. For example, so if I draw anything more than 1 meters, so it will automatically be a red line instead of a white line. That's all.
Okay. That is the checking mechanism inside our script that will check the sketch segmentation that Zaim created earlier. So let's say in the sketch, the segments that Zaim created is larger than 1 meter. It will prompt the line as red. So that is the checking mechanism inside the KNOWLEDGEWARE script. But here, what I can understand is during the scripting itself, error while editing the parameters. Okay, normally when there is any error detected by Katya during parameters modification or changes, there will be an error prompt box. Okay, the error prompt box will pop up inside our Katya environment, and it will say which features in our specification tree got affected by the parameter changes, and subsequently which features is being affected by that feature in error. So I cannot demonstrate it right now, but normally you can see this during any parameter related changes or feature related feature changes. How can I put this example in words? Okay, let's say normally, right? Normal parametric modeling, you have a cube. Okay, I'm always using a simple cube as explanation. Okay, let's say you have a simple cube, 1 meter by 1 meter by 1 meter, right? And then you control a certain hole in relation to a vertex of the cube. So in subsequent changes, that particular vertex got discarded. Okay, so the feature related to that particular vertex will be in error. Okay, so that error will be prompted out by Katya to you as the user, so that you can determine which vertex has been discarded, and you need to replace that vertex with a new one. So I think that's the example that I can put forth right now. But Ms. Nur Amalina Fakri, if you have any particular model that you are referring to, you can get back to us. I will leave our email inside this video description below, so you can contact us directly if you have some sort of really particular example to refer at, because we don't see any example right now. That's what we can say. Okay, we move on to the next question from Danalitika. Alright, if I want to modify an instantiated UGF cube, let's say they have dimple and top circle without changing the whole set, how we do that? Okay, so in in demonstration by Zaim earlier, in the first demonstration, he demonstrated that we can create two cubes by using UDF, right, Zaim?
Yep.
Okay, let's say one of those cubes you want to have a dimple or top circle. So once a UDF has been instantiated into your session, you can manipulate that cube or that UDF as per normal feature in Katia. Okay, you can do any manipulation to it. You can add holes to it. You can add fillets to it or chamfer to it. It doesn't really restrict you. The function of UDF instantiation just now is just to expedite your design process. Okay? As shown by Zaim earlier, to create that particular cube solid in direction of the given curve and in the position of the given point, you need to have some sort of processes. Okay, the processes are set. So by using UDF, we can put a shortcut to it. So by clicking a single click on those UDF, you can directly get the cube solid. So once the cube solid is in session, you can do further manipulation to the cube solid using normal Katia features. I hope that answers the question. And how easy that will be? It will be easy. Okay, so the next question came from Ilya Bashira Hamizi. Can the UDF be saved and reused later in another file? I think Shimi, can you answer this?
Okay. Can the UDF be saved and used later in another file? The answer is yes. UDF can be saved in CAT or CAT product, and we can access via catalog later on. So the answer is yes, Ilya.
Okay. All right. Okay, we have another question from Mr. User. Alright, say after all modification has been done, there are bound to be some unused elements left all over. But still in the tree diagram. Okay, my question, can we delete those unused all at once with maybe some auto comments? I see. Zaim, do you know how to do this?
Actually, wait ya. So okay, from my experience, all the unused item can delete, but I don't know if there's some auto command to delete all these um unused on trees in Katia. So you can delete all the unused items.
I'm actually opening up my Katia V5 right now because normally I'm using Katia 3D experience. It's been a long time for me since I used Katia V5 that extensively. But during my time of using Katia V5, I remember there is a function called delete unused elements, or is it called delete useless elements? I'm not sure. That's why I'm opening up my Katia V5 very quickly right now, but it hangs on me. Let me try to check it. Zaim, have you open your Katia V5? Right?
Yep.
Yeah, I understood Mr. User's intention. He wants to clean up his specification tree. So not only sketch, we also normally have some curves or lines or points that are unused, and we never know which one is used and which one are unused. So it's better for Katya to run the checks for us and see which elements are used and which elements are unused, so that we are not accidentally deleted anything that I use. You understand my language or my English? Why is it happening here? What is behind here? Zain, Can I share your Katia V5 screen?
Yes.
And maybe you can help me navigate the features. If my memory serves me correctly, I can point you to the correct location of the features. Hopefully. Okay. Maybe you can open a new CAD.
Right. Wait.
The new CAD.
Okay.
Okay. Let's see in the tools menu. Okay. Hold on. Do you see any delete unused elements there?
Unused element.
Delete useless or
Delete
unused
useless element.
element. That is right. So, Mr. User, in Part Design Workbench, if you go to the Tools menu, you will see there is a function, came OOTB by Katia. Okay, out of the box, we have a function called delete. What is it called? Zain? I cannot see it.
Delete useless element.
Useless, right? Okay, not unused. So my memory serves me correct. Delete useless elements. So once you click on that function, try to click it, Zain. There will be a dialog box come up. Okay, there is nothing here. So maybe you can try to create a sketch. In fact, create two sketches.
To sketch.
Yeah. Oh no. Two separate sketches. I mean, sorry.
Alright.
Okay, create another sketch. In the same part body, Zain.
In the same body. Alright.
Yeah. Just two different sketches. Okay. Alright. So now, from the second sketch, you pet a simple solid from the second sketch.
Sorry, is?
From the second sketch there, from the second
Okay.
sketch, okay, create a pet. Yeah, that's okay. Okay, now try to use the delete useless element. Okay, see there is a prompt out box. Okay, dialog box given by Katia. So here you can choose which feature you want to delete, and from this dialog box you will know which feature is not used and which feature is used by other feature. I hope this answered the question earlier by Mr. User. Okay, by this function, you can definitely clean up your specification tree from all the garbage lying around in the tree. Okay. All right. We have a confirmation from Frieza. Great.
Okay.
Okay. Okay. Let me quickly browse back the comment area and see whether we missed anything. I think we have covered every question in here. We have a feedback from Nora Malina Fakri. Okay, we answered the question as well. Okay, so I don't see any new questions coming in from our comment area. I think we have covered all the questions given, and it looks like we have exceeded our time actually. Okay, so for those of you who are viewing this live webinar in recorded format, you can definitely interact with us later. You can submit your questions in the comment area. We will still actively recheck this recording after this session finish and see whether we can answer any future questions related to this topic. Okay, before we wrap up, Shimi, Zaim, do you have any more things to add?
No, Iskandar.
No, Iskandar. Thank you for help.
Okay. It's my pleasure to have both of you here. And also it's great to see all of you again, although it's virtually. And hopefully this COVID-19 will be over soon. Keep on following all the SOPs and together let's defeat this COVID-19 pandemic. While you all are here, do check out my Katia Knowledge playlist inside this YouTube channel for more informational videos on KNOWLEDGEWARE. Okay, so we will see you next time in our future webinars. Our next webinar is scheduled on Wednesday, 2 weeks time forward, the Wednesday, and it will cover a brand new topic. Okay, so see you again next time in our future webinar. Thank you all for joining. Bye bye.
Thank you. Bye.
Bye all.